Hi everyone. Good evening. Good afternoon, guys. Good afternoon, everyone. How are you all? Everyone, how are you? So hope you're all doing well. So now in today's class, right, what is the discussions we'll be having? You can say that a shear center discussions will be having if you just observe, right? Is na? In the previous classes, right, what are all the things we have discussed if you just observe? That shear stress the shear stress calculation equation is na, and the bending stress calculation equation, right? Those are all the things we have seen or not, right? Now we'll be seeing which one. This is shear center wala, right? The shear center, regarding the shear center we'll be discussing, you can say, right? So all of you had your lunch or not, everyone? Yeah, Pavan, good afternoon. You had your lunch, everyone, all of you? You had your lunch or not? Right. Now, so all of you, welcome to Unacademy. Let's crack it. So this is my profile, right? What is this? Right? This is my profile in Unacademy. You can follow me at which, okay? Right. What is that? A referral code you have to use, right? Whenever you are subscribing to the plus courses, iconic courses, or whatever the courses you are having, you need to subscribe to which one? This plus courses and iconic courses, using which one? This RPC will code. Yes. What special you had? No. These are all GATE 2024 toppers. Those who are secured AAR1 from Unacademy. Next time you get your name here, right? And photo here. So like that you have to work. And at present this biggest offer is going on. So that flat 55% off on all the GATE subscriptions you'll be getting. And that too with 1 month extra subscription on your 3 months subscription you'll be getting, right? This offer is valid up to which one? This October 27th only, right? So tomorrow will be the last date for this offer if you just observe, right? So here, when you are preparing for this GATE 2025, if you are taking 3 months subscription, you will be getting this 1 month extra, and the total cost comes to be that 5,499 only. Okay, what is that referral code you have to use? RP Civil is the code you have to use, right? In 2026, if you are preparing for, you will be getting that 15 months subscription, at which one? This 14,999 rupees, right? And at 24 months if you are getting, right, that is your 19,999 you will be getting if you are preparing for this GATE 2027, right? So GATE 2025, GATE 2026 and 2027, right? All the three options will be there, right? And you can get the assured rewards for you in this Diwali. This is valid up to which one? This October 27th only. You can win iPhones, MacBook, gaming consoles, and more with Unacademy. You can just spin this and you can get this, all of you. Okay. Right. So what are the batches started? Let us say for 2025 aspirants, these are the crash course batches started, right? Latest batch started on which one? This 11th October. Before that, I have started this highway engineering, you can say. And in this batch, geotechnical engineering by Amit Zeroda sir has started, you can say. No, RP Civil is the code you have to use, right? So 2026 aspirants, right? There was a batch, latest batch started on which one? This is the 25th October. So environmental engineering by Jaspal sir, environmental chemistry by KP sir, and surveying by Abhishek sir, right? As now these are the subjects started. And a Nischay batch for this 2027 aspirants, right? So this was also started on which one? This is 25th October only. So same subjects were started if you just observe, right? And based on your GATE previous rank, is not GATE 2023 or 2024 rank, and based on your ESC qualification, right, you will be getting up to this 90% scholarships, right? And if your BTech percentage is also higher, you can get further scholarships, right? If you are a college from the, if you are a student from the prestigious institute, also you'll be getting this much discount on your GATE and ESC subscriptions. Okay. So these are all the features of this plus subscription. And if you wanted to take iconic also along with the plus subscription features, right, these extra features will be there for this iconic. And these printed books delivered to your home within 15 days of your subscription, you can say, right? Now coming to this, right, what is that we have discussed if you just observe in the previous class, you can say, right? So I'll just go through it and recap. So this was discussed na, bending stresses, and this bending stress equation m by I equal to F by Y equal to that E by R is na, that the moment of resistance, shear stress is na, shear stress equation, right? This is 103. Equation for this shear stress we have discussed now, isn't it? Now coming to this, so here this is your quick revision section 16. SOM quick revision, right? Shear center will be having, you can say, is na, and that is your 103 point, na, so that is your 103 point, you can say. If you just go for this is your which one, this 104, you can say. So in this 104, right, what is that we'll discuss? If you just observe that a shear center we'll discuss, you can say, right? What is that we'll discuss? If you just observe that a shear center part we will discuss, you can say. Now, what is the meaning of this shear center? Tell me. Yeah. What is the meaning of this shear center? Shear center, shear stresses, right? All this will come under this same topic only, right? What is that a shear center comes into picture? If you just observe, everyone. What is the shear center, everyone? Suppose if there is a load is falling, right? Whenever there is a load is passing through the CG of your cross section, right? What happens to this load? Tell me. When load is passing through the CG of your cross section, right? What happens? So it will be creating which one, this twisting also, no? So now whenever twisting occurs, right, its capacity will be same or its capacity will be reduced. If you just observe, whenever twisting is lesser, twisting is there. When twisting is there, it will be creating this distortion in the shape automatically. Whenever there is a shape changes, moment of inertia changes. Whenever there is a change in the moment of inertia, it automatically, right, what happens? You can say that capacity of the section also changes now. So that is why, right, what is that we need to do? If we are passing load through a particular point, what happens? Tell me. Torsion should develop or torsion should not develop, right? Torsion should not develop, right? In case of bending, right? That point is called as your which one? This is shear center, you can say, is na? So what is that shear center? If you just observe, yeah, right, yes, about which rotation will be starting, you can see, if you just observe, right, isn't it? Right. So what is that you can say? Actually, it is the point at which shear center is which one? It is the point at which what happens? Tell me. It is the point at which resultant shear stress, right? It is the point at which if resultant is a point through which if the resultant, right, if resultant shear stress or shear force, na, FORC, resultant shear force acts, then what happens? Tell me. Then the member is subjected to which one? This is simple bending only, no? Then the member is subjected to which one? Tell me. Simple bending only. So it is a point at which if resultant shear force acts, or you can also consider it as which one? This, if the load acts, load or this resultant shear force acts, right? So it will be subjected to which one? This is simple bending only. So simple bending only means, right, what is it you can say? No twisting will be there, obviously, na? So no. Will there be any twisting or this no twisting will be there, you can say, right? No twisting will be there, na? So no, no twisting will be there, right? So it is also called as your which one? This is center of flexure, no? It is also called with which name, all of you? It is also called as your center of flexure, right? So because that is only resulting in this bending, na? It is not resulting in this torsion, right? So that's why you call this with which name? Tell me. Center of this flexure, you can see, just right, isn't it? Got it now? That shear center. Now, so here, right, so what is that you can say? Location of this shear center. So shear center, it is better we have to pass our load through the CG or pass our load through the shear center. Which one is better? Tell me. It is better we have to pass our load through the shear center, na? Is that no? Now tell me, location of this shear center, right? Where is it? How can you identify this? Location of which one? This is shear center. If you just observe, how can you identify this location of this shear center? If you just observe, there are different points, right? What is it you can say? Right, Here, what is it? You can say first and foremost point is what? Shear center does not coincide. Okay. Shear center does not coincide with which one? Tell me. CG in general. So in general, what is that? You can say it is coinciding with the CG or it is not coinciding with the CG. It is not coinciding with the CG in general, except at which situations? Tell me. Except if section is symmetrical about both the axes. Na? Symmetrical with respect to which one? This both axes, right? Symmetrical with respect to which one? This both axes, right? So if you just observe it, okay, it always lies on which one? That is shear center always where it lies. Tell me if you just observe. Shear center always lies on axis of symmetry. Na? It always lies on this axis of symmetry. You can see if you just observe it. Suppose if you are having a channel section like this. So when you are having a channel section like this, right, what is that? You can see if you just observe, this is your channel section. And now tell me, right, where is that CG axis? If you just observe, this is your CG or this centroidal axis. Now tell me, and where is that shear center present? Right? That shear center present will be on the outside of this one. Na? Isn't it? The shear center will be present on outside the cross section. You can say, right, outside this, but it is present on this x-axis symmetrical axis. Na? But is that YY symmetrical axis or YY is not the symmetrical axis? That YY centroidal axis is not the symmetrical axis, therefore it is not coinciding with which one? This Y, you can say, is not? Okay. Suppose if both axes of symmetry are there, right? Suppose if you are having two axes of symmetry, right? What happens? Tell me. Both the CG and the shear center will coincide. Na? So if you are considering this axis, if you just observe, this is your vertical symmetrical axis, absolutely, na? And this is also which one? This is a horizontal symmetrical axis, na? Now here, right, what happens? Tell me. This is only SC, this is only which one? This is CG, right? Both are coinciding. If you just observe, right? Only if both the axes are symmetrical, then shear center will coincide with the CG. Otherwise, in this left side one, is that shear center coinciding with this CG or shear center is not coinciding with the CG? Tell me. In the left side one, shear center is not coinciding with the CG, na? Right? So you have to be careful. Done? No. So that is where it will happen if you just observe. Right? Now, are these noted, everyone? These points are noted? Noted? Okay, note this and tell me. Then I'll move on to the next point corresponding to the location of this shear center. Noted? Okay. Now, so here, what is that point? You can say that is your 105 and this is your, okay, sorry. Yeah, here still it is there. Na? Now, so what is that? You can say if the section is made up of this two narrow rectangles, when section is made up of which one? This is two narrow rectangles. Two narrow rectangles means that two narrow strips, na? Yes or no? Then the shear center, right? Where is that shear center lies? You can say shear center lies on which one? On junction, right? Shear center lies on which one? This is junction of which one? This is both rectangles. If you just observe. Okay, it lies on both rectangles if you just observe, right? Isn't it? Now if you just consider it, whenever it is a T section, so this T section means, right, this is your first rectangle and what is that you consider? This is your second rectangle, no? Is that no? So you are having this two rectangles only or not, right? Two rectangles only. Right now, tell me, this is your x centroidal axis, but it is not an axis of symmetry. But this is your, which one you can say that axis of symmetry only, no? That y axis is the axis of symmetry or not? That y axis is the axis of symmetry, but x axis is not the axis of symmetry. Now tell me, right, what is this, right? This is your CG location, and where is that where is that shear center lies? If you just observe, where is that shear center lies? That shear center lies on this vertical y axis only, exactly above this CG only. But here, there, here, where it lies, if you just observe, exactly at this junction. In this junction, that shear center lies. Okay, at the junction of these two rectangles, it will be lying. Is that clear now? Clear or not? Now, suppose if you are having some L section or this angle section or whatever it is. So this is your angle section or this L section only, na, all of you. So whenever you are having this L section, right, what is it you can say? If you just observe, this is your, right, yes, this is your, which one? This is CG axis, na? If you just consider, this is your, which one? This is CG axis, you can say. But where is that shear center present? At the junction of these two, that is where that shear center is present, na? Is it clear now for this, all of you? Yes or no? So like that we can identify the shear center location, na? Isn't it? Suppose if it is like this also, right? Same only, just if you are rotating it like this, right? What happens? Tell me. This is one rectangle, chota bacha. This is another chota bacha rectangle. Right? Where is that CG? Tell me. CG will be present at this place. And where is that shear center present? At the junction of these two. That is your shear center present. Na? That is where that shear center present. If you just observe, right? Is it clear now? Is it now? Right? So that is how we'll be identifying which one this is shear center location. Is it clear now, everyone? The location of this shear center and what is it you can say? Location of this shear center and what is it you can say? Location of this shear center and this one. Right. Uh, what is the meaning of this shear center? Okay. Clear? Right. So I'll be closing the session now. And in the next class, what I'll do is the shear stress variations will be having, right? The shear stress variation in different cross sections and the shear center equations for different cross sections we'll see. Okay, that we'll see in the next class. Okay, clear? Everyone clear now? Okay, thank you. Have a good day. Thank you.